Hello everyone. Today we are going to solve one very interesting number theory problem which says that this number is given, that is 2 to the power 37 minus 1, and it has a prime factor between 200 and 300. We have to find that prime factor. So before we start to solve this problem, one very helpful theorem is there which we are going to use here to prove this problem. And this theorem says something like this: if p is an odd prime number, then each prime divisor of 2 to the power p minus 1 is of the form of 1 mod 2p. What does this mean? So if you take 2 to the power any prime number, for instance say 5 is an odd prime number, then this number will have all its prime divisor are of the form of 1 mod 2p. Means here all prime divisor must be of the form. Okay, what is the meaning of 1 mod 2p means? Those who don't know, 1 mod 2p means numbers of the form 1 plus 2p multiple of 2p, where k is some multiple, right? So for example, you know that this number 2 to the power 5 is 32 minus 1 is 31, and 31 divides this number, means it's a divisor of this number, and clearly 31 is equals to, if you notice here, it's 30 plus 1, or you can say that 2p. Here p is 5, 2p means 10, 2p k plus 1, that is p is 5, so 10k plus 1. Here 10 into 3 plus 1. So you saw that 31, the number 31 is of the form 2p k plus 1, some number, right? So if I give you another example, suppose say you have some number like, you can take 3. If you take 3, this is going to be 7, and 7 also of the form 2p some multiple plus 1. How? Here p is 3, so 2p is 6. 6 into 1 plus 1. So this is also of the form 2p plus 1. Right. So this is very helpful here. And now we may start solving this problem, because 37 here, 37 is an odd prime. Well, friends, I am not going to give proof of this theorem. You can find in any number theory book, standard book, which uses Fermat's little theorem to prove this one. I am just giving one application here. So it means 2 to the power 37 minus 1 must have prime divisors of the form 1 mod 2p, means 1 mod, here p is 37, so 2p is around 74, mod 74. It means of the form 1 plus 74k. So all of its prime factorization must be of the form 1 plus 74k. It means which numbers are of the form? You can clearly know that these kind of numbers are 71, 75. So here friends, you know that these types of numbers are this, and so on. So because here already mentioned is a factor between 200 and 300, clearly this is the only number which is in between 200 and 300. It means 223 must be a factor of this number. Okay, so if you divide this number with this one, friends, actually it turns out that 2 to the power 37 minus 1 is actually equals to 223 into number is product of 223 and this number.